Okay, we're going over investigation 10. This investigation goes over what probability is. We haven't done much probability this year yet, but if you think back to other grades, we have worked with probability before, and that's figuring out what the chance is of an outcome. So, for example, I have this spinner drawn here. If we assume that this spinner is balanced and fair, that all of these parts are equal, then we'll be able to figure out the chance of us spinning an A, the chance that we spin a B, and the chance that we spin a C. So, go ahead and look at page 636 on number 1. Number 1 says, if the arrow is spun once, what outcomes are possible? Well, if we spin this, we're going to only be able to land on 3 letters. We have an A, we have a B, and we have a C. There are no other options for an outcome. Number 2, on which letter is the arrow most likely to stop and why? So, if you look at this spinner here, we see that the letter A appears 3 times on the spinner. Letter B appears 2 times on the spinner, and the letter C appears only once on the spinner. So, which one's more likely? This one. Because there are more of them on the board. Half of our board is filled with the A's. Okay? You're going to have a greater chance of landing on this A than you are of the B. Same goes for the B. You're going to have a greater chance of landing on the B than you are than the C. Number 3, write the possible outcomes of a spin in order from least likely to most likely. Well, the least likely of an outcome will be letter C because there is only one of them on the spinner. The next least likely will be B, and the most likely will be A. Okay? Now number 4, which outcome of a spin is twice as likely as the outcome of C? Okay? Well, this C has only one possible place to land, and letter B has 2 possible places. And isn't 2 just doubled of 1? So that means that B is twice as likely to land on it than you would be with C. Number 5, if the arrow is spun many times, then about half of the outcomes are likely to be on which sector? So, let's say you want to spin this 100 times. Where do you think it's going to land about half of the times? If you just look at this spinner, you see that half of the spins, the possible outcomes for the spins, are A's. So, that means that you're going to land on A about half of the time. Number 6, if the arrow is spun many times, so let's say 100, you spin it 100 times, what fraction of the spins are likely to stop in sector C? So you're going to spin over and over and over and over again. You're going to have so many tries, and it wants to know how many times you're going to land on this letter C. I'm going to draw a chart on here so I can color on it. Here's your letter C. You have no other letter C's here. So if I color this in, what would the fraction be, okay, for this letter C? Okay, I just redrew it from here to here so that I could actually color on it. So if we're trying to find the fraction, we need to figure out how many pieces total there are. That's going to be your denominator. So there's 1, 2, 3, 4, 5, 6 pieces. there's only one sector possible for a letter C. So we just have a 1/6 probability for C happening. So for number 6, that would be letter A. Letter A is 1/6. Number 7, we have another multiple choice. In 60 spins, about how many times should we expect it to stop in sector C? So, sector C, this is the same picture I just drew down here. So we have about 1/6 of a chance. Okay? All right, on number 7, it says in 60 spins, about how many times should we expect it to stop in sector C? So this is the same exact picture over here as up here in our example. I redrew it, remember, just so I could start drawing on it. We figured out that the probability of the spinner landing on the C is 1/6. You have 1/6 of a chance. So number 7 wants to know how many times we should expect the spinner to land on C if it spun 60 times. So in a perfect world, we would take the chance, or that probability, 1/6. We need to find 1/6 of our 60 spins. Okay. When we take a fraction of something, that means you need to divide. So we're going to take 60 divided by 6. You should be able to do this in your head. We know 6 divided by 6 is 1. And if it's a multiple of 10, then you add those zeros. So 60 divided by 6 is 10. So we should expect it to land on C 10 times. But is that going to happen? Probably not. That's just the probability of it, the chance of that outcome happening. So in this problem, we figured out that there was a 1/6 chance of C happening. Now, what if I asked you what the chance of the spinner landing on either the A, the B, or the C? So the options would be limitless, right? You would be able to land on any of those 3 letters that I just told you. So if you're certain that it'll land on something, or that the outcome is going to be true all the time, 100% of the time, then your probability would be 1, okay, or 100%. So all probabilities are going to be either 0 all the way on that number line, all the way up to 1, okay? So if you're certain something's going to happen, it's going to be a 1. If it's in between, like up here, where it asked you, how likely is it that it'll land on the C? Well, it's going to happen once in a while, so it's not 0. It's not never going to happen, but it's not always going to land on 1. So that's why it can be in between this 0 and 1. All right, go to the next page, 637. We're still using the same spinner. Okay, it's still on your page on the top right. So number 8 says, what's the probability that the arrow will stop in sector D? Why? Do you see a sector D? Do you see a section on this spinner that has the letter D? Nope. So what is the probability that it'll land on D? 0. There is not going to be a time ever that it'll land on D here. Okay? That's because there is no D. Number 9. What is the probability that the outcome will be one of the first 3 letters of the alphabet? Why? What are the first 3 letters of the alphabet? A, B, and C. Okay? So they're asking on number 9, what's the chance, or that probability, that it will land on one of those? Just one of them, not all of them. So does it have a chance to land on A? Yep. Does it have a chance to land on B? Yep. And it has a chance to land on C. Okay? So if you spin it, it is for sure going to land on one of these. You are certain. So if you're certain that something's going to happen every time, that probability is 1. All right, number 10. What is the probability that the arrow will stop in sector C? Okay. We actually answered this on number 6. So if you go back to that, it said if the arrow is spun many times, what fraction of the spins are likely to stop in sector C? We said that that would be 1/6. Okay, we drew that little chart. The C was here, so I colored that in. The fraction was 1/6. So if you get asked what the probability would be if it lands in C, it's the same thing. You're going to have 1/6 of a chance there too. All right, we have a new picture to deal with. Instead of a spinner now, we're going to move on to a dice. Okay, I just drew the same cube that's in your book. Okay, now number 11 asks you what numbers are represented by the dots on the faces of a dot cube. Okay, we've been talking about faces the past week. So on each face, you're going to have the numbers 1 through 6. So for number 11, you're just going to write down all of those numbers. 1, 2, 3, 4, 5, and 6. Number 12. If a dot cube is rolled once, which number is most likely to end up on top, and why? Well, on a cube, on a dot cube or a dice, you don't have any numbers that appear more than once, okay? You don't see 2 4s appearing on this dice, okay? So you're not going to have one number show up more than once, okay? That might happen just because you roll the dice over and over again, but it's never because of the way the dice is set up, okay? So there would be none. Okay? There's no number that's going to end up on top most of the time. Number 13, we've got a multiple choice question. If a dot cube is rolled many times, about how often would we expect to roll a number greater than 3? So greater than 3 is this 4, 5, and 6. Okay. So these numbers, 4, 5, and 6, these are 3 numbers. Now, how many numbers total do we have on a dice? We've got 1, 2, 3, 4, 5, 6. So if we have 6 total numbers, and they're wondering how often we would roll a 4, 5, and a 6, well, that's 3 numbers. That's half of this. So we should expect to roll numbers greater than 3 half of the time. But remember, that's not how it's always going to be. We should just expect it to. That's what probability is. So number 13 would be letter B, about half the time. All right, number 14. If a dot cube is rolled just once, what's the probability of rolling a 7? Do we have a letter or a number 7 on a dice? Nope. So the probability is that it'll never happen, so that's going to be 0. There's never going to be a chance you roll a 7. Okay, number 15. With one roll of a dot cube, what's the probability of rolling a 1? Okay, well, we have 6 total numbers on a dice, so that's going to be our denominator. And there's only one sector or one face on the die that's a 1. So you just have a 1/6 of a chance. Number 16, another multiple choice question. How would we describe the likelihood of rolling a sixth with one roll of a dot cube? So we have the answer is very likely, just as likely to roll a six as not to roll a six, unlikely, or certain. So if you have 1/6 of a chance, let's think of a number line here. We start at 0 and go all the way to 1. If we're talking about 6, we need to make 6 equal parts in between 0 and 1. So 1/6, 2/6, 3/6, 4/6, and 5/6. So if you have 1/6 of a chance, that's going to be about right here. Is that likely that it's going to happen? One would be that for sure you're certain it's going to happen. And likely means that it's going to happen most of the time. This 1/6 is way closer to the 0 than it is to the 1. So it's going to be very unlikely that you roll a 6. Okay, just 2 more questions for you here. So throughout this lesson, I've been using the word chance just to kind of represent probability, because I think you guys know the word chance better than you do probability. So I'm just going to read this paragraph to you. It's on the bottom of page 637, and it has chance in bold. The chance of an event is sometimes expressed as a percent, from 0% to 100%. For example, if a meteorologist forecasts that the chance of rain is 20%, then the meteorologist is stating that it might rain, but that it is more likely not to rain. A forecast of 100% chance of rain means that the meteorologist believes it is certain to rain. So on number 17, it says the weather forecast stated that the chance of rain is 40%. According to the forecast, is it more likely to rain or not to rain? So if they say that it's 40% chance, well, we know that in between 0 and 1, or 0 and 100, they're saying, if we're talking about percents. Let me move this out a little bit. There we go. So if we have a scale, okay, halfway between the 0 and 100 will be 50%. So if they say there's a 40% chance of rain, that's going to be about right below the 50. So that means that there's going to be, it's more likely that it's not going to rain here, okay? If it was higher than 50, then it's more likely that it'll rain, okay? The closer we are to 0, okay, if we're below that 50 line, then the less likely it is. So number 18, the meteorologist now says that the chance of rain is 80%. 80% is above 50, and it's getting closer to that 100. So it's about right there on our line. It says that, or it asks us if this means that the chance, let me back up. Okay, it says this means that the chance it will not rain is what percent. So they want us to figure out what the chance it is that it won't rain. So if it's right now at 80%, what's the difference between knowing for sure that it would rain? So we got that little difference here between 80 and 100. To find that difference, you can subtract or you can add up. Okay, if I subtract 100 minus 80, I will get 20%. Okay, or you can count up from 80 to 100. 80, 90, 100, so 10, 20. So number 18 is 20%. I hope that helps. If you want and you have a dice or a couple dice and you want to do this with a partner, You could even do it on a Zoom call or Google Hangouts, but the next 2 pages actually have some experiments that you can do with probability. So, let me know if you have questions as always. Otherwise, I just went through all of your homework that you should have to do for tomorrow for math.